Good. Um, Thanks everyone for being here, and thanks Tane for reaching out to me and organizing this thing. Um, Super quick introduction about me is like Tane said, I was a ex-E employee 4 years back. Then I uh, started my own company. It's called Canvas. We also have a product with which goes by the same name, and uh, Sketch is like a consumer of. So Sketch is what I'm calling as rebuilding OpenClaw for teams to be used as you know, with a group of people or multiple people. So if you look at OpenClaw, right? Uh, if you go to its repository, the first line it says is um, OpenClaw is your personal assistant meant to be run on your devices, right? So, and I also saw a tweet by the creator recently. He was trying to help someone who was setting it up. They were non-technical, and he was telling them that make sure you understand that it's your agent. Don't put it in a group chat. So the idea is that so for today's discussion, we will go through the architecture, what it means, like what trade-offs they would have taken to come up with the architecture for a single person, and what trade-offs would you take to build it for multiple users, right? So I think that sets the context. I can also give a little backstory. So this is about Canvas. So Canvas is basically a workflow automation tool similar to NA10, for example. So I keep on looking at and trying to figure out a lot of workflow automation tools. People keep on open sourcing those as well. NA10 is one popular one which is open source. This was last year December, and I saw OpenClaw. I think it had around 1,000 stars back then. It piqued my interest. I set it up and started using it, and I had set it up for I exposed it to my team as well in Slack. So now everybody, and I didn't think about what it has access to and whether how does it resolve an individual user, and how does it differentiate between users, right? So I thought that it would do that, but everybody has had access to all my data, and that kind of was a revelation that okay, this is not supposed to be done. And that kind of led us to thinking, because we were also thinking of a when we built Canvas, right? We were thinking that how would external because this is the era of agents, right? So you want agents to be able to use your product. So we were already thinking in that direction, that how do we enable agents to use Canvas. And this was a good refresher in the sense that this thing could connect with, obviously you could expose things with MCPs, but this thing could connect with products in a different way. We'll look at that as we go ahead. Um, so that kind of helped us come up with the idea of Sketch, and we'll look at the architecture of both today, and we'll try to see how each of them work. So just to set the context, I think all of us know what an agent is, but I'm just setting the context, setting the vocabulary so that we're on the same page. So an agent is nothing but a observe, think, act loop, right? And this has been there since decade in ML research. If you have read about reinforcement learning, this is exactly what we do in reinforcement learning. There is an observation of events. In the case of LLMs, it can be a user input as well, or any external trigger. Then you think, your core model actually thinks and it acts. So in this case, it became more accessible because LLMs kind of made it a bit more general. You can do any kind of reasoning with an LLM and not just a domain specific reasoning, right? So and this led us to other things, like for example, we do RAG, so you can inject memory in the context depending on the user's intent. So all in all, agent loop is pretty simple. I think we all agree that this is what it means. Um, one vertical in which we can divide agents is you can call agents as cloud native, which run like, for example, ChatGPT or Claude Chat, right? You just go there, maybe you connect your MCPs there, give it some external tool access, and it does work for you. Some of them can go even further. You can automate them, but they don't have access. What they don't have access to is a bash, right? Or your file system. So that's where machine agents, I'm calling them machine agents. This is not a like a established, these are not established names. I'm just trying to put a divide so that we can arrive at OpenClaw. So machine agents would be the ones which run on your machine or some machine, have access to the bash, have access to the file system, and can write code, execute code on that machine, right? So full access. And your layer for external integrations changes between the two. So cloud native would obviously be connecting through tool calls or MCPs, right, to external services. While machine agents, they are a bit more open. They have more surface area, so they can use CLIs. They can directly call APIs through curl. They can also use MCPs if needed. And this is what OpenClaw built on top of, right? So it's a machine agent which runs on a machine, and it added, is this visible? I don't think it is, but I'll just try to explain. So the idea is that OpenClaw kind of took that machine agent, and we were already using a lot of machine agents, right? Claude Code, for example, Codex, are all machine agents. And back then, no one had thought that I can access this thing remotely through any chat channel, right? So this is the groundbreaking thing which Peter Steinberger did. He created a framework on top of machine agents, and he added multi-channel support. So you have Slack, WhatsApp. They have now 30 plus channels, so you can use any of those, and your agent will be listening to all those channels, and doing the task whatever you say. Skills, so they added the support for skills, since you are running on a machine, so you can actually refer to files, read files, write files through the agent, and that kind of helps the agent to self improve as well. We'll look at skills deeply as we go ahead.
Yeah, just one second. Can you go back to the previous slide?
Yeah.
So these in general, yeah, that's okay. In general,
Can you
we
speak?
have,
It is for others, sir.
yeah, in general, we have cloud native agents. What is generally used in the industry?
Yes.
Cloud native is what is popular.
Yes.
And in what cases we are using machine agents?
For mostly for personal uses.
Yeah, right.
So Claude Code you will run on your machine. Claude Cowork you will run on your own machine, right? Nobody will access, your teammates will not access your Claude Code, right?
Yeah. Okay.
And right now they also don't have a solution where a team can access, they give you a sandbox of Claude Code and your team can access it. There's no such solution like that right now.
Okay. Yeah, right. Fine.
Just to correct, the cloud native agents also have access to local file system on the cloud, right? So
It depends if you give them access, you will have to give them the right tools. But this is something which is expected from the machine agents. I'm just trying to draw a line. Ideally, you would not want to give cloud agents access to Bash on a server, because then a user can do pretty much anything on your server. So, yeah, we'll move ahead.
Yes.
And one important thing which OpenClaw added was proactive. I like to call it as proactive mode, which is earlier people had not thought about that. You can actually run these things in a loop and make them do anything you want, right? Like on a schedule. So this was a novel idea back then. And obviously some security as well. We'll look at security from both the perspectives, what they've solved and wherever there is scope. Yeah, so this is on a high level the architecture of OpenClaw. Uh, I'll just look at the high level blocks and then we'll go through one like message flow of how it gets processed. Um, so there are obviously messaging channels. We already touched upon those. There are control interfaces. So what happens is when you install OpenClaw, you will get a script. That script will basically understand your OS, and it'll install all the dependencies along with OpenClaw. So OpenClaw is nothing but npm package. So that gets installed as a service, like a launch D or a system CTL service on your machine, so that it survives restarts. Then you typically configure it through their CLI, but there are other options as well. Like there is web UI, they also have desktop app now for Mac. They also have mobile apps now. Then there is the most important piece, which is your gateway control plane. So this is just a single node process, Node.js process, which is handling everything. Like there is no multi-processing. There is some multi-threading involved, but there's just a single process which is managing everything inside that is happening inside OpenClaw, and that is what we'll try to dissect today. Then we have the agent runtime, which is kind of embedded uh, within that control plane itself. We'll also see how that works. Then everything every configuration or every state of OpenClaw that gets maintained in the storage layer, which is nothing but flat files in a dedicated directory in your home directory. Right, and obviously it comes with the tools and other capabilities. We'll touch upon those as well a little bit.
Yeah, just 1 second. Can
Yeah.
you stay with the architecture once?
Yes, yes.
I think this diagram is not visible. It is very good, but
It's yeah, I think it is supposed to be like little bit more zoomed in, but because this is
you
a slide,
can't zoom it on your machine.
I can.
Because I think none of us are able to read what's written in the.
I understand. Yeah, let me. Is this better? This is the top half of it. I think messaging and control interfaces are pretty clear. This is your gateway control plane, and it uses a library called Pi to manage the agent loop. So this is the green block.
So, as of now, is this the only architecture? Yeah. As of now, is this the only architecture built on top of machine agents?
No. Obviously, there was Claude Code and others built, but this is more like exposing it as a service for you through different channels, right? WhatsApp, Slack.
Right. So that is the differentiator that this brings.
That's one of the differentiators.
Yeah. Right.
Yeah. Okay.
And is it also open source? Is that the reason it got a lot of traction?
It's open source. It's easy to get started with, not set up. It's easy to get started with. So a lot of non-technical folks realize that you can actually set it up and automate a lot of stuff. Uh, as devs, we were used to it through Claude Code and other stuff. But for non-technical people, this was a revelation, kind of.
Can you explain with the example of this architecture diagram?
I am going to do that now. Yes. I'll go back into slide mode. Let me know if you want a zoom in. I'll do that. I think this should be visible, right? So just looking at one message, how it flows through this architecture, right? So you have so initially when your message, let's say you message from WhatsApp, right? So OpenClaw has a channel adapter. Nothing but a single file which manages all the different aspects of a given channel. So when I say channel, I'm saying WhatsApp is one channel, Slack is one channel, right? So WhatsApp would have its own implementation within OpenClaw, right? We can discuss about how they have used this library to do it separately. But what the adapter does is it looks at, it takes the input and it will convert the input into an internal message format, right? Which can be used within OpenClaw freely. Then it passes it on to the access control. So this is the very basic form of security it has, that it just checks whether you're allowed to message or not who are you, only are you allowed or not. Then it does a routing which basically sends the message to the right agent. So there is this concept of mapping a session to an agent. Now again, some vocabulary stuff here. When we say session, it means a direct message or a group chat, or if it's in Slack's context, then it could be again a direct message or a channel. Within a channel, Slack has channels, right? So within a channel, that becomes a session basically. So the routing part, what it does is it will take your message and see which agent should handle it. So there is a session to agent mapping. We'll again double click on what I mean by an agent within OpenClaw. Once this is done, it goes into a session queue. So your queue is, this is an in-memory queue, that's one. It is maintained per session. So every session gets a queue. So for example, I'm sending a message and you are sending a message to the same OpenClaw process. Both of us have two different queues maintained, which means both our requests will be processed in parallel, but multiple messages from a single person will be processed sequentially, right? And I'll explain later how this helps, what this kind of unlocks from an agent perspective. Then your message goes to the agent run. So this is the loop which we discussed in the first slide, that this is the loop which runs with your message history and everything. It has tools, so it'll if it outputs a tool execution, then we'll execute the tool. If not, then it's text, then it goes to response delivery. Response delivery will take care of chunking the message to make sure that it doesn't hit the message character limit of WhatsApp, and you might get one or more messages. And that's it. This is how a message flows through OpenClaw.
At this point, can you take us to the agent run slide so that we can
I
correlate
have
with
it
that?
coming up ahead again,
Okay.
like
Yeah,
a little
fine.
bit more zoomed in.
Fine, fine.
Any questions on this, on the message flow? Cool, we'll move ahead. This is the This is the OpenClaw Workspace. This is basically the directory where I was saying it maintains the entire state of the application. So everything is maintained in files in this directory. I'll quickly give a rundown of what each of these do. So OpenClaw.json is the config file. That's where you configure pretty much everything related to OpenClaw, right? Or even if, or whenever you're configuring from the CLI, the OpenClaw CLI, that configuration will be written here and will be picked up by the gateway accordingly. Then agents are kept in an agents directory. Every agent has an agent ID, and there is a one-on-one or many-to-one mapping between channels and agent. You always have a main agent which handles your DMs, and you can have your groups also, group chats also. Same agent can handle them, or you can have multiple agents which separately handle group chats. So for example, you might want to limit the tools which you allow to the agents which are listening to the group chats, right? Then there are a bunch of files. So agents.md, I think we all know what this is. This is the Claude code equivalent of Claude.md. And this is where you define your rules that, do this, don't do that. Then you have soul.md, which I think this is an interesting piece. You should go to soul.md URL and read about what soul.md means. But this basically sets up the personality and tone. And there's a reason it's called soul.md. Uh, user.md is the user profile which the agent fills in when it first interacts with you. So this is basically information about you. Identity is for the agent persona. Memory is the long-term memory. So whatever is in memory.md always goes into your system prompt or your context uh, on every message. Tools.md is these are user specific notes about how to use specific tools. Like for example, you might say that whenever using bash tool, do not use rm command, use trash, something like that. So all those rules you can put it in tools.md. You can also put it in agents.md. There's no hard and fast thing about this thing, but yeah, this just keeps the separation. Then there is heartbeat.md. We'll click on this when we go to proactive agents, but you can define whatever you want the agent to check on and act on frequently. And in OpenClaw's case, that is 30 minutes by default. So every 30 minutes, it wakes up, checks the heartbeat.md, sees if there is something that needs to be done according to the instructions mentioned here, and it will do it. Then we have the memory folder itself. We will again go a little bit deep into this later on, but anything that you ask OpenClaw to remember, it will write it down here. That's something mentioned in its system prompt. So it will, whatever you say, hey, remember this about me. It might write it in about you, it might write it in user.md, but in general, if anything you tell it to remember, it mostly goes in memory. Then you have sessions, which are nothing but JSON-L files, which contain your interaction history with the agent. So these also obviously go in the context when you're interacting with the agent. And then there are skills. We'll again go into skills.
So that memory is there, right? That is, I think, every day, whatever is there is in the memory directory.
Right.
So if there's 1 year of memory, there are like 365.md files, lot of things.
Yes.
How does it pick and choose what to go in the context? Like it can't take the whole thing
So
in context.
memory is something that directly doesn't go into the context. It always searches it. So whenever search is involved, it'll obviously not pick up the entire thing. It'll pick up a subset from there. We will again go deep into how we can enable better search on it. And now they've kind of baked that thing into the product itself. Finally, we have credentials where it stores all the API keys and tokens. This goes as plain text. So that's why you would have heard a lot of stories about security concerns about OpenClaw, because you can imagine, right? Your agent can access this entire directory. It can read and tell you whatever contents there are. It can also update them. So imagine if you have your agent in a group chat, everybody has access to this directory, and they can ask it to give pretty much anything from here. Yeah. This is sketch architecture. Is this visible? No, right? Let me.
I have one question before we go to the sketch.
Can you take this?
Could you go back to the
Yes.
workflow? Workspace, sorry.
Workspace, yeah.
So during our usage with OpenClaw, are you saying this is the structure in which it gets populated, or do we have to, make any changes to this, for example, MD files to get a better output, or what is the understanding here?
The understanding is this is the imagine this is the working directory of the agent. It knows how to manage it, and whenever parts of it are managed by the OpenClaw process itself. So for example, whenever you're asking a question, I have this covered in the context piece, but I can talk about this a little bit here. So whenever you ask it a question, for example, it receives a message. It'll first assemble the context. So context assembly will mean that it'll read some of these files, whatever relevant files. Those are coded in the code of OpenClaw itself, and it'll build the context, the system prompt, right? And then it'll send it to the LLM, and it'll do its work and come back to you. So as user, you don't have to always worry about what's in here, but you're free to, in fact, you're encouraged to go look here what's in there, because over the time it would have accumulated facts about you, which probably are true or not right now. So you should be able to edit them and change them. And that's one of the powers of OpenClaw and why it got popular, because you as a user, imagine you would have seen ChatGPT, and Claude got this recently, but ChatGPT had this from quite some time, where it used to create memories about you. Initially, when they launched it, they also used to show that memory created whenever you tell it something interesting about yourself. Now they don't show it, but the reason people were sticking to ChatGPT was because it knew so much about them. And you would ask about, let's say, your kid, and it would know the age and everything. It would know about your family and everything, and that kind of brought in the stickiness. But the problem with that was a lot of the memory got obsolete. You can't change it. You can't, even if you ask it to forget it, it'll say I've forgotten it, but it'll be there. So that's the challenge as a user. That's the challenge you face with closed systems like that. Now here you know what's in there, so you can actually go and edit it.
And this role is referring to personality and tone of the agent.
Agent,
Not the user.
not the user. The only thing about user is user.md.
Yeah.
That's it.
And what about the agent argument? I mean, I see there's one agent.
Is this working even? Actually, this is meant for machine. Okay.
This recording.
Okay. So, agents, right? So, is this always a multi-agent where you have a leader and leader orchestrate to other agent, or there will be a scenario where you only have one agent?
Mostly you're supposed to have just one agent. Ideally, it can spin up multiple agents, sub-agents. We'll again look at that as well. And those agents are like they'll get the job done and they're gone.
But who is responsible then for probably maybe once we go deep down, I think those questions will clarify.
Yes. Sure.
So again, adding on to that, so if I'm visualizing it from a cursor perspective.
Okay,
Now,
sure.
as a developer, I don't have to worry about what agent I'm spinning up. I just enter a prompt. It is in agent mode, and I don't have to worry about the agent ID, which agent it is calling.
You don't have to worry here as well.
Got it.
Unless you're giving it to someone else as well, then you have to worry about it, because you have to be careful about the security. You can create different agents for different sessions, right? But as long as you are using it, you don't have to worry about it.
So how does multiple agents get created under this?
There is no, this is an interesting piece. There is no way for you to create agents by yourself. So you have to ask your agent, hey, create this agent. Yeah. Does that make sense?
In Hindi, we call it Naukar Kya
Is that?
Yes.
I think these agents are long-running agents. Am I
Yes.
right? So I think we have a SDKs coming in to create them, right? Like a Deep Agents SDK.
Yes. This OpenClaw also uses Pi SDK,
Okay.
which helps it manage the agent loop.
Okay.
So it's not managing the agent loop by itself.
Okay.
Yeah.
So if I want to create any of the machine agents, I can use any.
You can use Pi.
Harness. This is called like Harness SDKs, right?
Yes.
Okay. And
The level of harness is it provides kind of varies agent to agent. For example, Pi gives you pretty bare bones,
Okay.
and you have to build a lot on top of it. But that gives you a lot of control. I have that covered as
Okay,
well.
okay.
I
Fine.
have that covered,
And,
yes.
and quick question. I mean, what is that sketch? I mean, I missed that initial
Sketch
part.
is the
Your customized version of OpenClaw, isn't it?
it's the version which I'm working on. It's also open source, but it's meant to be used by multiple people
Okay.
within an organization.
It's again the AI assistant on your machine, correct?
It will not run on your machine because obviously multiple people will be using it. So you are supposed to host it somewhere in cloud. But the basic principles are same as what you see in OpenClaw. Everybody gets a directory like this. So you have to do some sharing between agents and users. So there is some design involved there.
Okay, exactly.
So that's what I'm trying to cover.
Okay,
Yes.
sure.
It was inspired by OpenClaw.
Yes. We'll move ahead.
I have one primitive question. Can you help me visualize what exactly OpenClaw is? Again, I'm thinking from a cursor perspective. In
Right,
cursor, we have an agent.
Yes.
Can I think of OpenClaw as so cursor has access to my folder, my
To your machine.
repo,
To your entire machine.
to my entire machine. But in the context, let's say a repo. Is OpenClaw, can I visualize OpenClaw as a cursor agent which has access to my entire machine? Is that the right?
Yes. But the only added thing is that you can message it from anywhere. From WhatsApp, Slack, Telegram, wherever.
Got it. That was the first diagram you showed where this channel and
Yes. Which we are calling as channels. Yes.
So can a channel and, for example, can Telegram and cursor be connected so that I can message from Telegram to cursor?
I'll cover that. Yes. I have that in one of the slides.
Thanks.
I thought from an audience perspective and then tried to cover whatever. Cool. We will move ahead. We were here. So I'll not go into each and every detail of Sketch's architecture. We'll go through, like, OpenClaw is the center of attraction here. We'll stick to that, but I'll keep on dropping hints on how this is done in Sketch, how this is how it's done in OpenClaw. Yes. So on a very high level, same concept. You have channels, you have a message queue, you have a single Node.js process. Here's one difference. I've decided to use Claude Agent SDK while OpenClaw uses Pi. I'll double click and show like what are the differences. Then for storage, we partially use the workspace itself because as users, this is what you're starting to expect from a machine agent, right? It has access to the machine. This is not a cloud agent where it'll not have access to the machine. So you can expect the mental model to go with this thing here is that if you've used Claude Cowork, has anyone? Claude Cowork, right? Similar to Claude Code, but meant for non-coders, right? So this is the Claude Cowork's version meant to be used by the entire team, right? So you have in Cowork, you give access to a folder and it has access only within that folder and it will do all the tasks within that folder. It can create files, it can do whatever. So same thing here, just that this is sitting on cloud on a server, and as a user you get access to one folder within the server, and your agent operates only on that. We'll again we'll go through how we enforce that isolation so that because it's agent, it can escape from the directory. And maybe a malicious user can make sure it escapes the directory. So we'll make sure how we enforce this thing. The rest of the configuration, etc., lives in a database. We support SQLite and Postgres both. So depending on your skill, if you're just trying it, you can start it with a SQLite, no configuration needed. When you want to scale it, you can put it in. You can migrate to a Postgres. It also supports MCPs. It has some internal MCPs for its own use cases. Like for example, it has an outreach tool which it can use to send messages to your teammates on your behalf. Like for example, you're talking with it, you ask for some information, it's not there in the memory, and since it knows your organization who does what, I'll show you how we configure that in Sketch. It can suggest you that, hey, this guy might know it, should I reach out? You can say yes, and then when they reply to, they get a message from their agent, and when they reply, we also get the response. Imagine using this on scale. Imagine you're a CEO and you are preparing for a board meeting. You want updates from 3 teams, 4 teams. You can just say, I'm preparing for this, go get updates from all these teams. So it will figure out, okay, head of marketing, head of sales, head of engineering, message them, get all the updates, consolidate and give you. So kind of makes your work easy that way. This is just one example, and some of these are common to what OpenClaw also already has. The REST API uses Hono. There is a React SPA. We don't want users to, obviously, no user will SSH again and again to configure everything into a server. So we have to give a nice UI for you to be able to configure everything. So it's just you install it and then you configure everything through the front end instead of doing it through CLI, in just like how you do on OpenClaw. I will move ahead. I think we'll be in this mode of presentation. I think we can zoom in easily, right? So coming back again to the agent loop, which we saw earlier. So now we can actually see a little bit more in action given the context we have gathered. So what's happening here is, so first thing that's happening is your context is getting built. We are starting from here, right? So the very first thing that happens is your agent system prompt gets built. Whenever you receive a message, your process receives a message, first thing you will do is assemble everything. System prompt, past messages, current message, right? And then you will send it to LLM. This is like fairly simple, same thing. I'm maybe repeating myself. And depending on what the response is, if it's a tool use, you execute the tool from your available tools and you follow the same process again, right? Because you have to put the tool results back into the LLM call. And then when it's text only, you send it to the user. There could be text in between also, like between tool calls also. You can send those also to the user. You can have a configuration around that. So this is one key takeaway when you're designing agents yourself. Make sure that you're addressing all these parts. I also want to double click on the context assembly because that's kind of important. I have seen a lot of those things kind of getting missed. From an OpenClaw perspective, this is what is happening when it's assembling context. It picks up your agents.md, picks up your soul.md, tools.md, a summary of your skills. Do everyone know how skills work? I will go through them deeply, but on a high level, how skills work. Okay, we'll cover them. Yeah. So your memory search results. So depending on how your search is implemented in OpenClaw, it has tools which it uses to search the memory on demand. So you have to explicitly tell it, hey, do you remember this? Do you remember the workflow we use? It will go search the memory. So here, this is where you have to be a little bit careful that you should know how it structures the memory. So like Tanay was asking, memory folder, anything in memory folder gets searched by the agent. Anything in the memory.md file, sorry, it's not mentioned here, that is something that gets picked up automatically in the context. So if you want your agent to remember something about your workflow, let's say you use a workflow very frequently, right? You don't want to explain it again and again, and you also don't want it to search it every time. You just put it in one of these files so that it always knows about it.
So you should figure out himself, right? And that's the reason we are using it. We only have to tell them that what you should remember.
Yeah, the unfortunate thing is, and maybe fortunate as well, that LLMs are not there yet. The LLMs are not there yet. But once they are there, then probably we will see agents like those. One way to actually bypass this is do RAG on top of your queries. You can enable that in OpenClaw, where you always do the memory search, right? You always inject it in the memory. Yeah.
So I have this confusion between a tool and a skill, right? So
We'll cover that.
we'll cover it.
Yes. So this becomes your final system prompt. Then there is some dynamic tool selection involved. For now, let's again we'll talk about MCPs and skills. But on a high level, it has some internal tools to read the basically to read the disk, to read files, write files, all that stuff, execute bash commands. So those get injected, and there is obviously message history which gets injected, and this goes to the LLM. Now, from a sketch perspective, it does pretty much same things. But this is one key learning I want everyone who is building agents to take away from today. Can I get a sense of who all know about token caching? Token caching? Okay.
You might not know correctly,
Okay.
but certain LLM support like they cache some amount of tokens. So certain LLM provider cache some of the token about your conversation, so that next time you don't load up that much context window.
Right.
I know. I think only I use Claude that supports it. I don't know about other LLM or provider.
We'll discuss in this in depth, because if you're building agents, this is the most important thing to know about. So we all see this. Okay, let me first say that what is token caching. So when you're sending a chat to an LLM, right, it is doing inference, right? So what it's doing is internally it's converting it into tokens. Those tokens go through a computation within the GPU where the LLM is sitting, where the entire network is, and then it produces an output, right? So those calculations are kind of costly, right? Before you start getting the tokens. So the idea is that you cache those calculations and keep them in the GPU memory. So that's what token caching means. And how you achieve it is that most of when you look at a chat, right, LLMs are stateless. So you're sending the entire chat, you're getting one small response or few tool calls, then a response. But and that adds up to your entire context. But this entire chat history is not changing at all, right? So what you do is you cache this entire thing, right? And your generated output kind of becomes the next input to the LLM along with the cache, right? So I hope I'm clear. This is your typical the way caching works, but just that this is like an incremental cache. So as your tokens get generated, your cache gets bigger and bigger. So if something changes in between, so for example, I go ahead and change, I have a long chat history. Somewhere in between, I go and change my Claude.md. It will invalidate everything in the cache underneath it. That makes sense, right? So imagine that you are building a financial agent, right? Let's say a trading agent. it goes and trade in the market for you every half an hour. And for that, it is supposed to know the time, right? It should know the exact time. What is the time now? I'm just setting up a hypothetical example, and you have two options. You either give it a tool to fetch current time, or maybe you put it in the context somewhere. Now, let's say you put it in the base system instructions. What would happen? So every time you call, your time changes, everything underneath gets invalidated in the cache, right? And that kind of is costing you a lot of money. So for instance, Claude, we were taking example of that. Claude has a different model. It rewards you for building around cache. So they have 90% discount on the output for a cache hit, right? So that kind of reduces your token cost a lot. So even if you would have seen that some models, they are priced very high, like Opus, but cost wise, if you take token caching into perspective, that reduces your cost like in the order of the its actual token cost is, right? So this is something we have to take care of. So this is just a map of how things get cached. So for example, this is from a Claude perspective. They cache the base system instructions globally. So again, this is specifically from a Claude code perspective, because Claude code has base system instructions that you're a coding agent, you have to do this, do that, right? They have specific tools, the read, write, bash, grep, which you can see when you're using Claude code. You have your projects, claude.md, and memory. So these two things are globally cached. These are cached per project. Then you have the session state, that whatever MCP, your additional configurations you would have given, they are cached per session, which means per chat. And then you have the message, which, like I said, they grow every turn, but if anything changes in between, that gets invalidated. So whenever, let's say, you go to a previous message, right? So you're actually making good use of cache there. You go to a previous message, again start your conversation from there. Your previous chat history is kind of cached there on the GPUs of Anthropic.
In terms of caching, right? So, say for example, I opened a chat, I typed 5,000 bits, right, and I send it to, right. So one is, you said that LLM. I mean, there is saving part of it, right? So caching is basically knowing the user, if I put it that way, right? So if I do not have a cache, LLM doesn't know me, right? So all your previous conversation typically, right? So caching, how does a caching actually saves you from LLM? Because I understand if you do a optimization on caching, saying that I type 500 bits and while sending to LLM you convert it to 200 bits, then there is a saving part of it. But without optimization on caching, LLM we'll never be able to save it anything, right, on LLM part.
So LLMs, you should treat them as stateless only. Yeah. So you don't have to worry about if they were not stateless, then you would be just sending them the latest message. Right. So your cache is not on the actual data level; it's on the computation level. So it is whenever it's doing GPU computations, it has stored that output itself, because that's what is costly. Right?
No, you mean output or the input? Input to the LLM is what we have cached, right?
No.
The output from a LLM is what we have.
Output, and we are not caching it. The LLM provider is caching it.
I got it, but okay. So okay. So we thought that input is what we are trying to cache. No, it's the output.
Input, anyways, we don't cache. We just store it because we have to maintain the history.
Okay.
We have to maintain the chat history.
Okay. But the saving part happens from an output part, so that you don't have to hit the LLM back.
Yes.
Is that the point? Okay. Got it.
it actually changes the perspective of the LLM, right? So usually LLM are probabilistic, right? Not deterministic, correct? So
Yes.
same input is not equal to same output, right?
Yes, yes.
So, but I think we need to be set the guardrails around that, right? So LLM, so we are not going to be probabilistic. We are going to be deterministic. So is that first guideline we have to fix? Because once we cache it, I think the response is going to be the same, correct?
Uh, Not really. Your response doesn't depend on the cache.
Okay.
Your response depends on a lot of other hyperparameters as well,
Okay.
which determine the, like for example, temperature or top
Yes.
K, right? So those always and interesting bit is these don't change the cache values.
Okay.
So the influence these parameters have on the non-determinism of LLM is
Okay.
much higher compared to your cache or your chat history.
Okay. And just quick question. I know we have this many layers of caching. So why can't we use that tool like a super memory, which is going to cache the context completely, right? So I think you would have heard
The
about
thing
it,
is
right? That's super memory AI.
we
Yeah.
have to cache on the like there is LLM setting on the GPU,
Okay.
which is doing bunch of computations on your input,
Correct.
right? You want to cache those computations,
Okay.
right? You can always
Not the
cache on your
responses.
end whatever you
Okay.
want,
Okay.
but those are the costly things that you have to cache, and those are not in your control. That's in the control of the LLM provider, how they have implemented it. The only control you have is you have to make sure that your
Before
prefix is stable.
Okay.
So your prefix doesn't change. That's why I took that timestamp example. If you put a timestamp in base system instructions, every time you send a request to the LLM, that timestamp will be different. So your caching will not work,
Yeah.
right?
Okay. Okay.
But if you put that timestamp in the, let's say in the current user message, so that's a new message. All the entire chat history is exactly the same. So that's a cache hit.
Okay. Just quick question around that. But if let's say, like for example, the invoice, it's something I want to view it, right? Or like analysis of my invoices for the last month, right? But I'll be requesting the same request multiple times per week, right? So timestamp changes, but the analysis remains same, right? Unless the next billing cycle comes up.
Right.
So how
that
to
level of caching you can do on your end.
okay on my end.
That's
Okay.
that'll save your token
Okay.
cost, right? Because you're not unnecessarily hitting the LLM.
Just trying to understand one thing. You said that when there is a change, like say in the input, then the entire caching related to that gets removed, right?
In one of these layers. So
Yeah.
whenever there is change in one of these, let's say you have this much of context, right?
Right.
Something changes here. So everything below it gets invalidated.
Okay.
The cache.
Not just taking from your example. Suppose there is just a change in the time of trading, right?
Right.
Now the rest of the, rest of the computation which has been done is actually still valuable for us. It's just the time which is changing. So can't we just instead of removing the entire cache, can't we just remove what is specific to the time part of it?
Yeah, and that's why I'm saying
Yeah.
instead of putting your time here, which is a frequently changing value, so whatever is frequently changing, you put it at the bottom,
Right.
or you make it available through a tool call to the LLM.
Right. So if you think of these as layers, so and then the thing which is changing most frequently, we should try to put it in the lowest possible layer,
Yes,
so
yes.
that the change in the cache is minimized.
Exactly.
That's the point. Right?
Exactly.
Yeah. Exactly.
Exactly. I had planned a break at this point. Break as in like just, but we have been asking questions and also I think we can go ahead. Shall we? Or I can ask one question which I had planned for. What coding agents are you guys using? Or what would you prefer? Claude Code, Codex, or Cursor? I think majority is Claude Code. Claude Code. Cursor. Are you using Composer 2? Composer 2. It got released yesterday. There is a nice controversy going on around it. We'll talk about it later.
I use Copilot very often.
Copilot, VS Code. Got it.
So far, I was only using myself when I came across a course in which it said create an agent to create a web application. Then I quickly started coming to sessions like these
Got it.
to save my job.
Uh, he's taking a question. He's asking a question. Then you can.
So you mentioned that they give you a 90% discount on cloud or whatever if you use caching, right? Now, is that for an API access you're talking about?
API access.
So how do you avail of that? And because
You just build around cache. Build around cache like this. So whenever there is a cache hit, they'll automatically charge you less.
you build this in your code.
Whenever you're building an agent, you have to make sure that your context is stable.
Okay. So in the sense that you yourself are sending less number of things for the cloud to process. That's what you mean to say.
Exactly. You're sending the entire thing, but they have it cached like that.
So you have to let them know that these are things which we have cached.
You don't have to explicitly let them know.
Okay.
They will know by. So what they'll do is, okay, let's look at it as a process. You sent this entire request to the LLM provider, right? Let's say Anthropic, Claude.
Okay.
You're using some Claude model. They take it. They see that if this, let's say they create a hash out of this, right? They see if there is a cache sitting in our system with this hash. If yes, they will take it, right? And the lesser for example, if you changed something in your Claude.md memory or somewhere in the middle,
Okay.
that cache kind of gets cut into half.
Okay.
Right? So it's a layered cache, for example. So you are sending an entire conversation. This much could match. This much could match, or this much could match. Depending on how much matches, that gets priced as per the cached input, and the rest of the thing they'll charge on the actual output cost.
Is there anything like when you want to build something like this on your own, like say, now this is your system which you have built. Is there a tool like build it, or you just tell Cloud that I want to build a cache for this, and build me something?
No. The cache is maintained by the. I can show you some code example. I think that will.
Okay, yeah, that will make much more sense.
This is not about you caching it. This is about.
No, I understand they caching it,
but you have to make sure your context assembly is stable.
Correct. That's what I'm talking about. How do you
I'll
do
show
that?
you some code example.
Okay.
Maybe at the end.
Okay.
Then that will be clear.
Yeah. Because that's the main thing, right? This API cost. OpenClaw, which I have seen, I mean, I've read, I've not spent so much because people say just setting it up is $40 is gone.
Yes.
So
that's why I'm talking about this, because so the idea is that we learn lessons from these things, and while we are building agents, we should be able to do it better.
Correct. Thank you.
Yeah. So my question was that while we are discussing about the layers, are these layers standard in the agent architecture, or do we have finer control over this? At what information we can store at the
Depends on your
levels?
agent SDK. Like you have 3 levels, right? You could be writing your agent loop all by yourself. You're making the call to Anthropic by yourself, or whatever LLM provider yourself, and then you build it from scratch. That's one option. Second option is you use an SDK like Pi, which OpenClaw has used. That gives you bare bones functionality in the sense that it'll give you a machine agent, but you will have to assemble the context yourself. Right? The third option is you use Claude Agent SDK. It works only with Claude officially, but it'll do some parts of it by itself. Like for example, it'll give you the base system instructions, the tools, Claude.md and memory. It'll solve it for you. So that part you can be assured that this will be cached. The next part is where your thing comes, where you have to design for it. So I can show you it in the sketch code, how we've done it, the rest of the assembly, because we are using those green part from Claude Agent SDK, and the rest of the parts we have to assemble. Like for example, there also you need some context about what this application
SDKs are giving a partial control over how things can be done, and some things are standard by default.
Yes.
A few SDKs like Strand SDK by AWS or Gemini SDK. Does those SDK provide you these ground level capabilities?
Some of them, yes. Some of the capabilities they'll give you, but some of these you will have to take to maximize your. It's not like that. So caching is a added advantage, right? Even in typical software engineering, your work will get done. Just that whenever there is a cache hit, you get faster response. All
And
that
here,
stuff.
in terms of messages, right, which you were saying, now if I want to optimize those messages also, instead of 200 bits, I want to put half. How do you do? Does
You-
this SDK gives you those capabilities?
No, it doesn't. It gives you Claude Agent SDK gives you compaction. So whenever you hit the token limit, it'll auto compact the just like Claude Code does.
But it does not
Gives
do
you
summarization of my text.
summarization. It'll do, yes. Compaction is exactly that. Summarization. It'll do that. It will. You can also control it in the sense that if you some people what they do is they'll remove the tool calls from the chat history, so that saves you a lot of context, but that'll invalidate your cache, so you have to do it at the right time probably. So there are nuances here. We'll move ahead. Cool. So small comparison on Pi and Claude Agent SDK. I think the most important thing is uh, the execution where it runs. So top is Pi and it runs within your own process. So what that means is from OpenClaw's perspective, it has a single Node.js process, right? So the agent loop is running with the within the gateway, within the gateway process. So which means whatever IO is happening is that's only the LLM calls that are happening, right? In case of Claude Agent SDK, it initializes a sub process per request or per user, right? Actually that it's per workspace wherever you're running it. So you have to give it your current working directory, just like you open Claude Code in a project, right? So it treats the current working directory as wherever you started it, right? So this is a stark difference, and now this kind of also explains why for multi-user, this is one of the reasons we used Claude Agent SDK, because you can actually scale it a little bit vertically, in the sense have a better machine which can do better multiprocessing, and this way you can have multiple users being able to use this. Right? This is one. Then Pi obviously supports multiple LLMs. It in fact maintains a layer uh, which kind of helps you connect to different providers. So let's say you are using Open Router or you want to use uh, Fireworks. So it will give you an interface to connect to any of those. Here you only get Anthropic or Anthropic supported. For example, you get Bedrock, or through Azure, you can use those providers as well. The other option is to use any Anthropic format supported provider. So Open Router has this option, for example, where they will change the response and request shape of any LLM for you with a setting where you can use it with the, for example, Claude Code. So if it works with Claude Code, it will work with Claude Agent SDK as well. So the restriction here is that the request response LLM request shape should be in the Anthropic format. Then control boundary, I think this is more about uh, how do you assemble context. I think this is something we covered earlier as well, where in OpenClaw or in Pi, your context gets assembled like completely by yourself. So you have they've written code to build the entire context from scratch. Claude Agent SDK gives you presets. You get a Claude code preset as well, where your agent will start behaving exactly like Claude code does, right? So it will be proactive in terms of writing code and everything. So imagine that you give it a like a long task which it has to do. So there are high chances it might end up writing code for it and do it. Like for example, call this API 100 times and fill this sheet or write this in a file. So it will probably write code for it and do that task. Isolation is something I'll touch base again on. But here on Claude, since it's a sub-process, there is OS level isolation per user. Blast radius, of course, because separate process, so it's kind of low. The complexity is high on OpenClaw side, not because they use Pi, but because they have a lot of other features as well. And if you want best control over your agent loop, you would go for Pi. If you want best reliability or you want to move fast, you want an agent loop fast, then you can use Claude Agent SDK. I think we are good to discuss skills. So there is an interesting thing about OpenClaw, which they decided that they'll not support MCPs. They support MCPs, but not in the traditional way. You can't give it a MCP. Let's say you have an MCP, you give it your MCP URL and it will get configured. It doesn't work like that. It doesn't support MCPs out of the box. And the reason for that is because Pi also doesn't support MCPs. And the reason Pi doesn't support MCPs is because the creator kind of believes that MCPs are a waste of tokens, which is actually true. I'll come back to this slide, looking at like what a skill actually looks like. But this is a comparison between an MCP and a skill-based approach for doing the same task. Let's say you have to. Everyone has heard of Playwright, right? You can control browser, use for testing. So Playwright has an MCP which has 21 tools and it has 13,700 tokens. That's like around 7% of your context window gone, assuming a 200K context window. And most of the time, these tokens are not used, even though caching kicks in and everything, but you're still sending additional context to the LLM, right? So this is a major problem with MCPs. I'm not saying that they are 100% gone with the skills approach, but I think whenever you're building agents, you might want to think that, can I do this with a skill, or should I do this with MCP, right?
When you say tokens, you mean tool description is what translates to token? Is that?
Yes.
Right?
Yes.
So the tool's description, pydantic, what you've written here.
Yes. So yes. So back to skills, and we'll come back to this slide again. So what are skills? Skills are basically this idea that most of the times an LLM does not need to know all the tools available to it. So they build on this idea, and the way they tackle this is that they ask you to define a skill name folder. So for example, in this example, it will be Vercel React Native skills, and you will have a folder with this name, and you will have a skills.md file in it. That file will have two things: a YAML front matter and a description of how to do this particular task. So in this case, this skill would define in its body, it will define what are the best practices to build React Native and Expo apps, right? And in the front matter, you have these fields which are parsed and sent to the LLM. So name and description are required, and you can have additional optional fields like license and metadata. And in the description, you would have phrases like this: use when building React Native components, or use when you want to do this, use when you want to do that, triggers on tasks involving React Native. So this kind of gives a signal to the LLM when to use this skill, right? So now if we look at the life cycle, what happens is, let's say your skills are stored in a folder. your process comes up. Taking example of OpenClaw, if we can go back to this slide, there is a skills folder here, right? So imagine there are 2-3 skills here. One is, let's say, a PDF creation skill. One is a let's say a financial market research skill. So when the process starts,
Can you just tell us what all constitutes a skill? What would go into making a skill?
just one file, skills.md.
No, but what that file contains?
Just now I
Is it a
told.
set of instructions or like say a combination of instructions and tools and can you please
I'll show you one
mic?
example right
Just
away.
keep the mic in the center.
no, that's okay. My question is done.
Okay. I'll show you an example of the body of the skill, but this is like the top part of the skill, right? I'll show you the body as well of the skill. Then we'll have a clarity. Just allow me to finish this thought. So what happens is when your process starts, you load this front matter into the LLM's context window. So only these many tokens are going. These are hardly, let's say, 100 tokens, right? And now your LLM has, let's say, you could give it a skills tool or read skill tool, or if it's a machine agent, it knows you can tell it that skills are stored in this directory. It can directly go and read the skill whenever needed. So now let's say I'm asking it, hey, I want to build a React Native app. Can you help me with it? So what it will do is it sees in its system prompt that I have a skill called React Native skill, right? So it will, LLMs are now being pre-trained on this, that they know what to do with skills. So they will go and read the skill either directly from the disk if they know where it's stored. Claude Code actually gives a tool called skill to itself, where it'll pass the skill name and it'll get that file will get read by that tool and passed on to the agent. Now agent has the entire context. Okay, how do I build a kick-ass React Native app? Right, and it will start helping you from there. So it has got a process of how to do something skillfully. Right, now you can club this thing with a CLI. Right, so for example, there are some npm packages which help you build PDFs from Markdown. Okay, so you could create a PDF skill and say that use this CLI to write a Markdown like this and then convert it into a PDF. And trigger this whenever a user asks to create a PDF. So imagine how you would do this in MCP. You would have tools to actually, you would have a tool which actually takes an entire Markdown or something to pass on to a process, a function, and that function calls the SDK or whatever CLI, and it finally gives you the PDF, right? And that PDF again comes in the context window, right? So it's kind of saving you two ways. One is you are not all the output of whatever the LLM is calling is hitting the context window, because any tool call through MCP hits the context window. So it stays in the context window. Imagine like a 2 MB PDF being in the context window. That's like unnecessary overhead. But in this case, the LLM, what it does is it runs a bash command to create PDF from a Markdown file, and it's done. Right? And it can give you the path that, hey, I have it stored here. So this is where skills can be combined with the CLIs to actually do the same stuff which MCP offer you, but kind of helps in saving the tokens. I'll take a pause here. I think this was a bit involved.
I'll ask. But I mean, I'm just confused. So MCP, when I say you have a tool description, you have an actual implementation of a code base at the rate tool, which gets you a job done. So you write a custom workflows. In skill, I can only sense that it's an English text, which LLM is getting into. So if I want to define my custom workflow, which is very tightly linked with my enterprise, my software calls, how do I put that in English words? Because I used to do it with the Python code base now. Now, how do I translate this?
You can put Python as well along with the skill.
Oh, is it?
And
So-
you can refer it in the English that refer this file. So we call them resources that you can ship with. I can actually show that to you now. So let's go to Anthropic's skills. So these are a bunch of skills which Anthropic has published. Let's look at the docx one. So there is one skill.md. It has name, description. Use the skill whenever user wants to create, read, edit, manipulate word. You have the entire stuff about how to go about this. It also explains how to use this CLI to make changes. Write output.md and that gets converted to bunch of other things. It also explains that use the script here to do some action, right? And that script is here. So bunch of scripts.
Script could be any programming language or any business logic.
Whatever can run on your machine. We are talking about machine agents, so they
But
can
then
do
how
all
does
that
it
stuff.
save the cost? So, I mean, you have a tool description on MCP. You have a same skin description here. So, where is the saving part which
Saving
actually...
part is two-step. One is progressive disclosure. So you didn't put the entire skill in the context window upfront. You just put a description of it, and whichever skills you can put 100 skills there, only their descriptions, hardly let's say 1,000 tokens, right? And
But in the case of MCP also, you only send tool description as a context, right?
yeah, but you send all the tools, all the input, not just tool description. You have to send the schema as well.
Right.
So if you take 10 parameters, you have to send description of 10 parameters.
So here, if my scheme needs 10 different parameter, I still have to send it as an English text to that guy, right? So
Not right away. Not right away. You can put it in the skill description.
Okay.
But whenever, sorry, not in the skill description. You can put it in the skill body, like how it's done here. It didn't start explaining about this Python script in the description, right? It just said what this skill does, right? Use this whenever this thing needs to be done. If at all you never do that in the life cycle of this chat, then why would you waste tokens having everything in the context?
Yeah, so just to use an analogy, it's almost like a hyperlink to a web page.
Yes,
like,
yes,
yeah,
yes,
that
yes,
is where we
exactly.
are storing the main content and
Exactly.
minimizing what we need to give to the LLM. And here there are no tools as such, because the scripts and all are only doing the
Scripts
task
are
which a
your
tool
tools.
would have done,
Yeah,
right?
scripts are your tools,
Yeah,
and
right.
since it's a machine agent, it can compose those as well. Let's say there are two different skills. They ship with two different such CLI instructions. It can actually compose them together, right? It could do one task after another, or it could, let's say, if it has to generate documents in bulk, right? Do you think it'll execute the script 100 times? No, it'll write a Python file which invokes this script 100 times, right? So that kind of again saves tokens. Yes, exactly. So Manus is a hybrid sort of agent. It's a machine plus SaaS agent, and it has access to a machine, but it's again a cloud machine which is like dedicatedly available to it. It's not running on your machine, or doesn't have access to a particular machine. Spins up machines on the fly to do some task and then kill them.
I asked Manus to create a PDF, so it used the Linux command to create.
Yes.
I have one question. So I'm developing a skill currently. So I'm stuck in that. So in the sense that in that skill, see what I have is I have a backend database built in Firebase and BigQuery. So I have functions, cloud functions built to do certain things, to compile certain things. So I want this skill to invoke those functions. And in those functions, I am again calling, say, Veritex AI to do some analysis on the data. Now, when I've made a skill like this description, and then I've given it all the context in terms of the functions, everything. Now, when I'm invoking that skill, it's doing its own thing. It's not invoking that function sometimes, or it's invoking the function independently and doing its analysis and giving it to me. So it's not going in the flow I want. I want it to use one function. When that process is done, there are certain flags in the database also. and then based on those flags, it has to invoke another function.
Got it.
So it's like it's not following my commands; it's just doing things randomly and then coming back to me. So
I think could be there could be a bunch of things which you could address here. We can discuss separately. One is obviously the LLM, like how right now, if you see a lot of LLMs publish their results about how good is it on agentic tasks. So all the LLMs which would be good at using skills should be good at agentic tasks, and that kind of
so maybe the LLM I'm using Kimi 2.5, whichever.
Kimi
Maybe.
actually is good at agentic tasks. We can discuss about this. Like
Okay.
this could be like structure of your instructions, like what could go in, what should go, like what should be deterministic, what should be non-deterministic. The different.
But the
workflows
flow
demand
is fine, right? I can call cloud functions through it and then take that output and then go to the next.
Yes, yes.
That part it can handle, right?
Yes,
It's not
should
like
be
I
able
have to just stick to the static thing and all that.
Yeah, of course.
All these things
Yeah,
can be done.
Yeah. In fact, we Sketch uses Canvas skill, which actually makes call to the APIs. I'll show you that as well. And shall we continue?
Yeah.
Sure. I think we are running time. Okay.
So does this skill becomes a complete alternative of MCP, or there are some cases where MCP will still make more sense than skill?
I haven't seen where like situations where it can't replace, but there are situations where you don't have much option. Like for example, in Sketch, if you've seen, we've used MCP because those are internal tools for Sketch to consume stuff. I don't have an option of so Claude Agent SDK doesn't support direct tool calls. So you have to define an MCP for it to access or invoke certain tools, right? Most of the time, you would want to balance on like how accurately you want it to invoke a function.
So my question was from the point that given a case, if I want to build my agent,
Right.
how should I balance between like in what cases should I prefer that I'm putting my context and skills, and for what specific cases
I mostly think about frequency. Like if there is something which has to be called very frequently, then it's okay to keep it as MCP. Again, I don't want to put like something like playwright in my even if it is used frequently. I don't want to put that because too many tokens unnecessarily. So again, you have to strike balance between frequency and the tokens.
Okay.
So if something gets executed very frequently, then I think it can be present as a MCP or tool.
So my understanding was MCP is mostly it helps with the data side of it. For example, if I connect my Zerodha portfolio via MCP, it's the data which is the connectivity is the key here. Now, how will I bring my portfolio data into a skill like? Can you help me understand how
Yeah.
I can replace Zerodha MCP to a skill CLI?
Yes, 100%. So this is something we have done in. There are more tools coming up like this, but this was created by the OpenClaw creator himself. This is called I haven't started. This is called MC Porter. This actually what it does is it will convert your MCP into a CLI, so that you can ship it with a skill. Right. So now what happens is. I have sketch skills. So this is so we have a Canvas MCP available, which you can use. So what Canvas offers is a layer in between through which you can connect different apps. You can give access to different apps to your agents securely. So you just share one credential with your agent. Let's say you share a Canvas API key, and then you give Canvas access to your GitHub or your Google Sheets or Drive or whatever, right? It has connectors built for all those. And it has an MCP for that, so that agents can use it. Like, for example, if they want to access my GitHub, it'll call the Canvas MCP to check whether I have added GitHub. If not, it'll tell me, hey, can you add GitHub? I'll give access to my GitHub. Then it'll again call the MCP to see, okay, I have access to GitHub. I can call these tools. I can read your repo. I can raise a PR or whatever. Right? So it can do a bunch of actions on my behalf through that MCP. Right? So now if I have to convert that MCP into a skill, what I've done is I've used this MC Porter, which is again a CLI. So what it does is you give it, I'll zoom into this. Where is it? Generate CLI. Okay. So you can run something like this, give it your MCP URL, it'll spit out a CLI for you, which will have which will give you help command to list down all the tools available. You will be able to invoke your MCP tools through this CLI. Right? So and now you have an interface, which is this CLI, which can connect to your MCP, which can call your MCP. Right? So that's one job done. Now you can define a skill on top of this. You can say use this CLI to do this, and ship it as a skill. So this goes as like a Canvas skill. So with the CLI, which is just a pure JSON file, can be invoked with Node. And in the skill.md, I've mentioned like when to use this and how to authenticate, how to invoke the CLI using Node. Right? So search apps, for example, is a tool within the MCP server available, but that becomes a sub command within this CLI. Right? So and it takes a query as a parameter. So that queries becomes a argument to this CLI. Since your MCP servers are highly typed, so you can do something like this. Right?
Another final question. Yeah. So, what do you think is the best place to enforce RBAC on skills?
This is a very good question, which I am also working on Sketch. This RBAC on skill. Okay, I can show you a slide which actually partially kind of addresses this. So Sketch skills are by default, admin can configure some skills which are global and available to everyone. As a user, you can define personal skills in your workspace, right? And when I say your workspace, it is one directory, like I showed you earlier, the OpenClaw directory, right? Every user gets a directory like that, right? So every user's workspace is isolated from each other. That is something we enforce on the code level. So when your agent is executing and it's making a tool call, we intercept that tool call and make sure that you are not accessing a path which you're not supposed to. So any work that gets done will be in your own workspace, right? So that's one level of role-based access. You could, it also boils down to a lot of other stuff. Like, for example, I have GitHub connected. That becomes a concern of, let's say, Canvas, not Sketch. So you can model it whatever way you want, as long as you can uniquely identify a user, which is what Sketch does, apart from which OpenClaw doesn't, right? It maintains a user directory. It also maintains a, hierarchy sort of, which like this, and it knows like who reports to whom, who can do what. You have to again obviously input this in Sketch, but once it knows this, it can do a lot of these actions on its own. So it's built like that, that it knows that it's working in an organization, so it'll respect the boundaries. Most of the things we've tried to solve deterministically through code, but some of them obviously can't be done like that. So some of them are in the prompt. The next step, we can jump on to the last slide now to wrap this up. There are a bunch of things, but I think we've covered most of these. What's next, basically? For Sketch, I think the memory is something we didn't go deep into, but I think we have covered we have covered it decently. For Sketch, I think what's important is every user has a personal memory, just like they could have personal skills and organization level skills. Similarly, you could have personal memory, you could have team level memory, you could have organization level memory. This is how things are done in this organization, blah blah blah, all that stuff. So that tiered context loading is something which we're working on, where we maintain the context in a single directory topic wise, and there again role based access comes into picture, where whether you have access to this topic, you are an engineer, do you have access to finance, things like those are covered there. Then event driven proactive agents, we talked about heartbeat and schedule tasks in the beginning. OpenClaw has this ability that you can tell it that do this every hour, or do this tomorrow at 9 a.m. So it'll schedule a cron, and that cron triggers the agent back, and your agent knows, okay, this is it stores a text, and it'll get that text, okay, this is what I was supposed to do, and it'll do it. So this is like an internal event. So this is something partially implemented in Sketch, and you can do event driven by saying that whenever a PR fails, do this. So instead of polling the PR, you could build an event driven system where your PR fails, that event comes directly to your agent, and it invokes and does something. Then external knowledge indexing is something we are working on, because in an organization a lot of context lives on external apps. Then there is dedicated agent team members, like I was showing here. You could have specific agents doing like having very specific goals and very specific process which they follow, and working like an independent peer in an organization. On the OpenClaw side, what I have not covered are following three things. Nodes, so it has ability to actually connect. So let's say you've hosted it somewhere, or you have three laptops, you've hosted it in one of your laptop. You could connect the other two laptops as nodes to it, and it'll be aware of them. You can also tell it that I use this laptop for this for this, and then it can, whenever you give it a task, it'll try to map the right action to the right node. You should definitely explore this. Then they have introduced a plugin system which combine, let's say, a channel, a model provider, tools, skill in a one kind of plugin, which allow you to do a bunch of tasks together. And then lastly is ACP, the question which you were asking about. How do you connect your cursor to a channel? ACP is the agent client protocol, which is like LSP, language server protocol, is for languages, right? So that helps you connect any agent to any channel. So this is a recent advancement which has come up. I think OpenClaw implemented it last week. This is something you should check out. I think we can close here. This is good. Thanks everyone. You can give a star to Sketch here. It will be really helpful for me.
That's the least we can do for you after the Sketch.
Thank you so much.